Okay, so we continue with our capture the flag challenges. So remember the tool we are using is sokonalysis, which is the Cipher toolkit built for skill levels. So for now the repository is still private. If you want a copy for this particular tool, you can simply give me your GitHub username or email address. Okay, so you can install this particular tool on Windows, and you can also do the same in Linux using the provided commands. So for your first time run or execution, you see this notice for the user agreement terms, which says this tool is for educational and ethical use only. Do not use this software for any malicious, unauthorized, or illegal purposes. So if you agree, just say yes. So this is the way the tool menu looks like. So this tool has 3 levels. The first one is the university level, which is aimed at helping out students to solve basic cryptographic algorithms such as RSA in their exams, tests, or any other given assignments. The second level is the capture the flag level, CTF, which we are currently doing or working on. So this helps a user or participant to utilize these two to solve cryptographic challenges until they find the corresponding flag, minus them utilizing a lot of resources. Then the last level is called the advanced level, for which we are yet to start to implement for the enterprises or organizations. So these are the current supported algorithms so far. Now we jump in for today's challenge. So this challenge is called saassrarr. So I don't know how to read that. So basically this was solved about 237 times. Then 388 people tried to solve this, and it's rated medium with 100 points on CyberTalents. So let's find out what this is. So triple power encryption. Okay, so as usual, we click on the link, we download that particular file. So it's saved in this particular folder, so based in your case it will be in another folder. So just extract or unzip that particular thing until you get a corresponding folder. So if we go in this folder, we can see we have 2 things. We have the cipher text and the encrypt.py. So just to be curious, we can check out the encrypt.py. So we can see we are given the value for n, which is this, and we also have the value for e, which has 3 values. Okay, then if we look at this particular code, they are trying to encrypt a flag, which is coming there as the output, the cipher. So here this particular m is being appended to the first e. 0 means this first thing, then n, which is that value, then plus 1, then they are putting the second e, then comma n plus 1 until the last one. So this is the way they are encrypting this particular thing. So again, here we have the cipher text. So this is the corresponding cipher text which was produced. So based on those values which we can see n, e, we can know that okay, that's just RIC. So without wasting time, we just need to open up the tool, which is sokonalysis. So we'll say / then the name, which is sokonalysis. So agree to the terms. Then on option 6 you can see this capture the flag. Then here we are looking for RSA. Now here there's a trick. When you're solving RSA challenges, it's advised that you first factor out the values for n using factor db. So here it's already implemented. You can just go online and search for factor db if you want. So I'll paste the value for n, then I'll press enter. So you can see it was querying with the database, the actual factor db, which is the website I'm talking about. So since you have these factors, you can simply copy these factors because they will help us to solve that challenge. So these factors are the ones which are making this prime number n. So here I'll just say, okay, I'll just paste these things here so that we don't. So let me just copy the value for p in advance. So now I'll just say yes to continue. And then I'll go back on option number 6. Now I'll go on option number 1, which is RIC. So This challenge we are dealing with right now is under this category, which is saying decrypt C with N and multiple E's. Okay, so here we are just decrypting C with N and multiple E's. So there's another thing which is similar, which is this, but if you look at this one, needs us to also have the value for D. In our case, we don't have that value, so there are multiple options which are actually similar to this one, but we are going to utilize this one because we can see there we also have a +1. So we'll say 23. So enter number of prime numbers of N. So if we can remember, the prime numbers are 1, 2, 3, which we have factorized, which is P, Q and R from N. So we'll say 3. So once we do that, so enter prime factor 1, meaning just enter P. Remember we are given copt P, so just paste. Then they will tell us enter factor 2, in this case, which is Q. And then now the last factor, which is R. So again we just copy this third factor, then paste. Then they are telling us that the corresponding N is actually this. So if we compare the N which was given, it's the same one. So enter the number of public exponents. So again, comparing our N, this is the same N. But the good thing about that method is that instead of us coming out with the factors manually, we've already provided the program with the factors. So we can see we have 3's which are equivalent to 3, 1, 2, 3. So here we'll just enter 3. So we have 3 is. Then the first one is this. So we come to the second one, which is this. Then the last one, which is this guy. Okay, so now we paste. Then now from those particular given values such as N and this private and is, we've gotten our private key. Okay, so now we just need to paste the value for C. So make sure that it's in decimal. So if it's not in decimal, just make sure you convert it to decimal. So now we just paste. So let's see. Alright, so maybe I just made a mistake when copying one of those particular values. So you can see now I've just pasted those particular things, which was the value for P, Q and R. Then we were able to generate this value for N. Then just pasted those 3 given values, which were the public exponent for E. Then we are able to derive the value for D for each particular value for E. Then with that we just pasted this decimal ciphertext. Then after that we are now able to retrieve each and every particular thing by subtracting a 1 from D. Remember, this algorithm is using +1, so we are subtracting a 1 from each and everything until we get this particular flag, which is triple prime RIC. So if we come back here, we just see my submissions just to confirm that everything is accurate. Yeah, we can see that to be the correct flag. So this is the flag and you get your 100 points. So thanks for watching. My name is Asoko James, representing KMU Cybersecurity Tutorials and the developer for the tool sokonalysis. See you in the next video.